So impedance, how do these networks transform voltage and current? So we are going to see just by adding an inductor and capacitor in shunt, how my voltage or current or power is getting transferred. So assume that I am going to excite the network with a sinusoidal input whose RMS value is V in. Then the power delivered at power available at the input port is going to be V square by R. You know, power is going to be only dissipated across the resistance. So either I can write V square by R or V square by real part of Zn. The real part of Zn is going to be my resistance. And power delivered at the output is going to be V out square by RL. If the network is identical, then the ratio V out by V in is going to be a root of RL by R, the real part of Zn. So this is going to be the formula for any lossless matching network whose input impedance contains zero imaginary part. That means I can clearly say the output side also I have pure resistance. The input side also I have a pure resistance. There is no reactance in my input side. So P in, you know, it is V in into I in, and P out, you know, it is V out into I out. Similarly, you can have an expression in terms of ratio of current. So instead of taking the power in terms of voltage, if you take the power in terms of current, you get I square into R. Here also I square into R. So if you take that ratio, you get root of real part of Zn by RL. See, in the previous case, you get the inverse of that. Root of RL by real part of Zn. Okay. So if, for example, if a network is transforming RL to a lower value, it